Hi, good afternoon, everybody. Thank you for attending this webinar about the IoT Marketplace kits. My name is David Bordonada, and I'm in charge of this website where you can find the solutions ready for the IoT challenge. I have been working in Libelium for the last 10 years, in charge of the Libelium online shops and the partnerships in America. Today, we're going to focus on smart parking solutions. So I will introduce our partners, Simfony and YazamTech, to start a quick tour along their dashboards. After the demos, we will start a questions and answer session. Along the webinar, I will have an associate here with me, Anna Bernal, who introduces the IoT Marketplace in a dedicated webinar before, will be attending the chat and will be answering your questions, sharing some links interesting for you, and facilitating contact details. During the webinar, all the questions you have will be classified by topic, and after my presentation, I will try to answer some of them. In any case, at the end of the webinar, I will share with you my email address so that you can contact directly with me. If you don't have time to join the webinar, or if you need to log out in the middle, in a couple of days, a link to the presentation will be uploaded in the webinar section of the Libelium website. Lastly, as you have already noticed, the session will be in English. So please, we will thank you to do the questions in the chat in English as well. Thank you very much, and let's start. Firstly, let me share with you the main points I'm going to talk about this webinar. We will introduce you the chain of value in the IoT world, the main pillars in the IoT, and how Libelium is approaching the solutions to everyone through the specific kits in the IoT marketplace. As said before, this webinar is focused on the smart parking. So we will have two demos from our partners, Simfony and YazamTech. The main difference between both kits, apart of the software, of course, is the connectivity used in each kit. Symfony uses LoRaWAN connectivity, while AsanTech uses Sigfox. After the presentation, we will go ahead with the questions and answer session. According to the last article about the smart parking project in Montpellier, driving around looking for a park space is part of the daily life for many people living and working in cities and major towns. As well as the inconvenient time stealer for individuals is extremely bad for the health of the city because of the pollution it creates. Smart parking solutions are moving up the smart cities agenda, and according to research and markets, the market is poised to grow in a compound annual growth rate of around 4.9% over the next decade, to reach approximately $1.4 billion in 2025. Libelium smart parking nodes use a magnetic sensor to detect the presence of a car in a parking slot. It uses double radio, LoRaWAN, and Sigfox to send the data to the cloud. And here you can see what's the position of Libelium in the IoT chain of value. We are providing the IoT sensors hardware platform, but we need to complete our products and services with cloud partners, software partners, and data specialists, because the users need to store, visualize, and analyze our sensor data. Well, and looking for offering a complete solution, Libelium decided to create the IoT Marketplace, a platform where customers wouldn't get lost, where they could find complete end-to-end solutions ready to use out of the box using certified products. Now, it wouldn't be necessary to choose a technology or a provider. The packaged solution would be offered. Let me explain you a little about how we have structured it. In the left menu of the website, you can find the different verticals with packaged kits: smart building, cities, environment, factory, parking, agriculture, water, air quality index, and e-health. We have added our new programming cloud service license to program the plug and sense devices quickly. Today, we're going to talk about our smart parking solutions and more specific in two of our kits. First, let me introduce Symfony team, who are going to show how to configure and use Symfony dashboard for smart parking applications. This kit is composed by 10 nodes and a multi-tech base station using LoRaWAN as a communication protocol to send the values to the cloud. Enjoy the demo.
Hello everybody, and thanks for joining our webinar on the Libelium Symphony Smart Parking Kit. In our session today, we will go over the software component of the kit. One key thing to understand about Symphony's platform is that the horizontally layered architecture provides all the necessary tools to design, build, and operate IoT projects. The platform features are not aimed at a specific vertical or industry, but rather provide generic features that can be combined in various ways for rapidly rolling out any IoT project. The Smart Parking Kit allows anybody not only to test a solution, but also tailor it to specific needs and effectively move from the drawing board to a live deployment. The kit comes along with all resources pre-provisioned, all 10 LoRaWAN-based parking sensors, plus the LoRa gateway connected with Symfony's global mobile connectivity service. This allows you to use the kit anywhere in the world. The Manage Devices tab allows us to provide each device with individual attributes or properties, and in the context of the Smart Parking service, the location is probably most relevant. Each device has a set of properties, which we call metadata, that will be used to hold this information. Let's configure these ones with GPS coordinates around the Libelium office. We can usually use Google Maps to get the coordinates, although in a real deployment, other methods can be used. We'll define two attributes for each device, holding the latitude and the longitude, and these will be later used, as you will see. Both the name and the value of the attributes are up to the user, and to save time, we'll only show the configuration of one sensor. Now that we have the details for each sensor configured, let's have a look at the default business logic that comes pre-configured with the kit. The application engine is based on Node-RED, which provides many benefits, most notably flexibility and speed of deployment. The default application logic is meant to receive frames from the smart parking sensors via the LoRa network, decode them, and then store them in a database. Each frame type is decoded individually and the appropriate action is taken. The frames that carry information about the status of the sensors are used to update this into the database, while control and configuration frames will trigger back the appropriate responses. The application comes along with a logic for calculating both parking session duration and costs. This information can be used for both statistical and monetization purposes. That is actually all you need to get things going. Now let's have a look at the simulated data and what can we do with it. All data saved by the application layer into the MongoDB collection is available into the reporting engine. This can be used to create custom reports based on the data and structure of the saved documents. We'll use the collection storing the live status of the sensors to create some meaningful reports. You can see here data fields available to the reporting engine, and we can select the wanted one to create several types of reports. Let's start with a table report that contains the name of the sensors, their status, the time and type of the last received message. We can save this report to make it available directly from a dashboard at a later time. Let's give it a name and assign it to a dashboard. We'll create a new one for this purpose. The reporting engine has several types of reports available, each with various grouping and selection options. Let's try another report, this time a pie chart showing the number of occupied versus free parking sensors. We'll use the status field as a grouping criteria and count as the report information. Oops, my bad, let me fix that. Now you can see the count for each status. The reporting engine lets you customize the look and feel, so let's give the fields a more friendly name as well as a more meaningful color. As you can see, this is quite flexible. Once we give it the wanted look, we can save it by giving a name and assigning it to a dashboard. We'll use the same one as before. Next, let's have a look at how our dashboard looks. Both our reports are here, so far so good. Probably the most useful report for the smart parking application is the map report, so we will build one. We select the appropriate type and provide the engine with the fields that hold the GPS coordinates for each sensor. We then select the info that we want to show on the map, and that is it. You can now see the data on a map. This is simulated data, so not many differences, but you can see that one of the sensors has a different state. This will get updated as the information is coming from the sensors. Now let's see what we can do with the cost and duration information. We can use the table format to get details about each parking session, the start time, end time, and the cost. Actually, let's add the duration as well. These are automatically calculated by the application logic and saved into a database. This one is expressed and rounded to minutes, but other options can be implemented. Another useful report is the sum of all parking sessions, revealing the total revenue on a specific time frame. You can select today, last week, last month, a specific interval, or none, which will make a sum based on all available records. I will put this into a more friendly format and add it to our dashboard. Let's have another look at our dashboard. You can see the details for each sensor on the map report, and this gets updated in real time whenever a frame from the sensor is received. The reports can be embedded in external websites or accessed directly via an URL, after this option has been enabled per report. For table report, there is also the possibility of downloading a CSV with the corresponding data if you want to use that with other applications or external services. The cost calculation can be individualized per sensor, for example, by using the metadata we've also used to store the GPS coordinates. This can be useful if you want to install the sensors in a different area of a city with different parking tariffs or even in different cities. The stored data is also available programmatically for those of you that want to use it with other external services. Each collection has all the needed details that are required to connect directly to the database. Data can also be pushed from the application layer whenever is needed. The main dashboard can be used to rapidly view existing reports, so let's add some of our newly created ones here. As said initially, the features presented in this session are just the ones that come by default, and the server logic is totally customizable to fit other requirements. We are looking forward to hear from you and find out more about your project, so don't hesitate to reach out. Thanks for watching.
After this demo from Symphony, we are going to continue with our partner YazamTech, focused on the smart parking solutions too. This kit is composed by 10 nodes using Sigfox connectivity to send the values to the cloud. Enjoy the demo.
Good morning, ladies and gentlemen, and welcome to this presentation and demo of the YazamTech SmartFlow platform. So the smartphone platform is our service platform, allowing you to connect your Libelium devices. So today I'm going to check and see how in practice you can connect your smart parking devices, manage them, control them, monitor them, and also provide value-added services to your customers like smart parking guidance and smart parking promotions. So all what you have to do as a Libelium customer is to provide us the data out of your sensors, and you can do that through your Sigfox backend. So we will give you the callback link, and you can configure it as per Libelium configuration manual. So this is in case you have your own Sigfox backend and you prefer to configure your own devices in your backend. Otherwise, you only have to provide us the device ID and PAC, and then we will configure it in our backend as well. So you have both options. So once you have done that, all the information sent by the sensor will be forwarded to our smartphone platform. You will be given a login password to connect to the platform, so you can do that securely. So once you've connected to the smartphone backend platform, you will have a monitoring center where you can monitor all your devices, all your smart parking sensors worldwide. So we provide it as a service, and you can manage all the smart parking devices in all the countries where you have deployed those sensors. So for each sensor you will see in the map, the sensor will have 3 states. Either it's in a free state, so meaning there is no car parked on top of the sensor. Busy in red color means that the sensor is detecting the presence of a vehicle, and not activated in gray is for the state, or let's say the initial state where the sensor has not been activated yet, meaning no messages have been sent by the device yet to the platform. So for all your devices, you can check the exact location, and by clicking on the device, you will get all the information related to that device. So the device ID, the manufacturer, of course in this case Libelium, the model, serial number, the hardware and software version, as well as other metadata information that you can maintain yourself. So we give you the capability to configure those devices and to add additional information. So you can update the firmware version. So every time you upgrade the firmware of the device, you can update the firmware version in the backend to keep track of all the versions of all your devices. You can update the metadata of that device. So in case you are delivering the sensor to your customer, but you are not the one operating and monitoring the sensor, you have those 2 fields, the operator and the owner. So the owner is the one buying the sensor from you. The operator is the one actually operating the sensor. So this is in case you deliver to municipalities, for example, and then you have an operator who is managing and operating the street parking. So you have also different classes for parking device, either public, so these are public on-street location, or you have special locations reserved for special vehicles or customers like taxis, pickup trucks, heavy trucks on the highway, a special disabled location for people with disabilities, as well as tourist buses, for example. So when you configure that on the application, the mobile application, these locations will appear differently to the customer. Of course, you can configure your sensor location worldwide. So the application gives you suggestions and recommendations for setting up the location of your sensor. And you can define different location types, either on street or off street, in case you deliver the sensor in a parking garage, for example, or in the ground, or a guarded terrain. You can always update the location. So the application gives you a very easy widget to configure the location of your devices, and you can change that based on your needs. Okay, so you can do that directly on the map. It's easy to use. You can select different map styles corresponding to your need, and you can create, and we can create actually for you, different accounts with different rights. So some accounts will have administrator rights in order to be able to configure the devices and change the configuration, but some others will have a user rights, where actually the user can only see the information but without the ability of changing any information. So depending on who you are providing this dashboard to, you can select the access rights. So for your customers, you can provide a read-only access right, but for your administrators, you can provide a read and write access right. So as I mentioned earlier, you only have to configure the backend callback in your Sigfox backend, or just provide us the IDs, the device ID and the PAC, which is delivered together with your device. And that's it. We will provide you the access login password. You can change it anytime, and you can use it to monitor your devices worldwide. So we, YazamTech, as a company, we will always make sure that the devices are up and running, that the state is active, that there are no issues with the device, and in case any issues either with the device or the connectivity or security, we will make sure to take care of it. So we do that because we manage all the devices in our platform, and we can, through the different dashboards, we can monitor all the devices, so their location, but also all the parameter of the device that it delivered as part of the messaging. We can also check the usage, so make sure that the consumption, the data consumption, is not exceeding your thresholds. So especially based on the rules that you will set up, based on the subscription plan you have with Sigfox, we can make sure that the consumption of the data that is transferred between the device and the network is actually monitored through the platform, and in case of any capacity exceeds, we can send an alarm and prevent overusage. We also monitor different rules. So these rules have been created based on the information communicated by Libelium sensor. So these rules will monitor actually different thresholds. So either the battery, for example, so we will monitor carefully the level of the battery. But we will also monitor all kinds of errors communicated by the device. And in any case, in case we have a trigger matching these rules, we will send an alarm and let you know. So you can make sure to either change the device or change the battery or reset the device if needed. We also monitor very carefully security and threats. So we have dashboards and capabilities to monitor the connectivity of the devices to see if there is any abnormal behavior coming out of the device or coming out of the network. So to make sure that there is no intrusion or illegal use of the platform. We can also, from our side, make sure that all the devices are configured correctly, and we do that through our backend by configuring the device and managing their configuration events. All right, so that's from the platform perspective. Just a reminder, as a customer, you only have to configure the backend of your Sigfox with the callback link that we will provide you, or provide us the ID and the PIC of the device that Libelium provided you, and that's it. We will provide you access to the SmartFlow platform, a portal where you can manage and monitor the state of your devices worldwide, and we will make sure that all the devices are up and running, and in case of any issues, we will trigger the corresponding alarms and make you know in a real time. For all the parking devices that you create, they will immediately be visible to the drivers in the mobile apps. So our Parking Hero mobile app is freely available in Google Play and the Apple Store, and it can be used and downloaded by anyone, anywhere. So by downloading the app, the drivers will have access to the capabilities of Parking Hero for driver guidance, parking promotions, and special parking management. So the users can use it to find available parking spots, so by opening the app, Parking Hero provides all the public parking location around the location of the driver, as well as the capabilities to search and find the right and the best parking location around the destination. So the customer can select the destination location. So the Parking Hero mobile app provides the location around that destination, both public locations, but also the street parking locations and the availability in terms of free and busy parking location on streets based on the information coming out of the sensor. So as an example, in this street, we have a total of 7 parkings, but only one is actually free. So for the driver, there is the capability and the options to select different locations based on the best options for finding an available parking spot. So by selecting the location, the driver can initiate the navigation, and the driver navigation will guide the driver right to destination. Of course, also using the voice over capabilities so that the driver navigates safely without looking into the mobile application screen. So the public locations like off-street parking and garages, information is also displayed in the app, including the status if the garage is open or closed, including the detailed location information. And for the location that you created yourself based on the sensors, all the information that you configured in the SmartFlow backend platform will be also displayed in the mobile app.
And before starting the questions and answer session, please let me remind you the calendar of webinars for the next months. The closest is the one that presents my colleague Andrea Manero to talk about industrial IoT. Don't forget to watch the webinar about the IoT Marketplace by Anna Bernal in order to get a more detailed vision of the different solutions provided to the IoT market. Well, this is the end of my presentation. It's time for questions and answers. Yeah, we talked about the... Well, for Enrico question about LoRaWAN, if you can use Libelium as a LoRaWAN base station. Unfortunately, Libelium doesn't support LoRaWAN technology, so you must use base station like Multitech or CarLink for LoRaWAN connectivity. In this case, the kit provided by Symfony includes the nodes, the 10 nodes of smart parking, plus the Multitech base station for LoRaWAN connectivity. Regarding to the question by Hussein, there is some countries that LoRaWAN or Sigfox are not supported, but in this case, you can use your own base station, your own LoRaWAN base station to create a private network to use the LoRaWAN connectivity. So in this case, with the Symfony kit, you can create a network using the Multitech base station and use the nodes connected directly to this base station. More questions? Well, we're going to share a link in order to buy the AsanTech kit, as asked by ZFF. You can buy directly in our marketplace, in the IoTmarketplace.com, and you will receive the package with the 10 kits. And there is a quick start guide in order to know how to configure the nodes with the AsanTech cloud. Regarding to the battery life of the nodes, it depends on the how often you are sending the information to the network. In this case, it includes a battery that allows up to around 5 years. You can find more information regarding to the lifetime of the battery in the technical guide that we can provide the link in order to see the lifetime of the battery. Regarding to the question made by Prasad, how we can connect Libelium devices with Symfony. In this case, the Libelium nodes for smart parking includes LoRaWAN connectivity, and you connect the Libelium nodes to a Multitech base station provided in the same kit. Then Symfony provides the capabilities, the features to configure the Multitech base station and connect to the Symfony cloud. Once you are configured the base station and your account in Symfony, you must log in your computer and access to the dashboard in order to get the information regarding to the sensor nodes in your account. Regarding to the question about Hussein about the contact with AsanTech, in the website you can find the AsanTech homepage in order to contact directly with the sales team from AsanTech, and they will help you with your questions about the dashboard. Last question for Guillermo Matov regarding to the frequencies in Argentina. Sigfox uses Zone 4 for this country. Okay, Zone 4 is available in Colombia, Chile, Argentina, and also Australia. Currently, our nodes uses Zone 1 and 2 only. So in this case, Sigfox connectivity in Argentina is not allowed with our nodes. In this case, you must use LoRaWAN as an alternative in order to create your private network using the smart parking nodes. Well, thank you everybody for attending this webinar. Here you can find my contact details, and please don't hesitate to contact me with any related questions you have. Have a nice rest of the day. Goodbye.